And we all know that humans are becoming smarter. And so are machines. And I think in between everything, humans and machines, they have inked a pact to survive together. So my first question is to both of you. How's the role of human in this machine era evolving, especially in the case of smart manufacturing and also for the future factories?
Shall I go? Yeah,
Yes, please.
There is an element of fear that I see also within this question. Usually it comes around that topic of what happens for the human labor and per se. Most the cases, looking at the history behind us, machines have displaced man hour more than replacing man labor per se, and that will remain to be the reality. And more of simpler, dumber tasks will go away, and people will get to do more variety of tasks. So which means multi-skilled will be necessary. A person who was manning one machine before, just feeding the item into the machine or whatnot, would now be responsible for 10 different stages of operation per se, right? So that's how evolution will go on, where most of the mundane presentation work would be taken by the machine, largely handling those variations, while the person will be occupied more with taking decisions around if the machine is changing things. The other thing that also have to be expected is how would the industry respond when you are blessed with such a infrastructure per se. Industries will also move on to accommodate more customizable products, which means variations like a Jaguar and Land Rover line or whatever that we may actually see. You'll have back-to-back different models of cars getting more customized and personalized to the consumer and so on. So that will demand back more intelligent labor force back into the system. So that's a transition that I actually see. And the structure of how this will evolve in man and the machine interacting with each other will move more towards people teaching machines than just operating machines per se. So that's the transition that I see. And I don't think you need to go to a school, enrich yourself with a lot of vocabulary and become expert in a subject to be able to do this programming of machines per se. So that's what is getting eliminated at this part. So it will be more about you translating your skills as you would do with your physical systems back to the machines. So that's the kind of interfaces, which means that this time transition to those to be able to man those machines doesn't have to be a new industry. It'll be a transformation of the existing industry in a different way.
Thank you, sir.
Yeah, I think Gokul has already highlighted. When I joined Samsung in 2011 and I visited for corporate orientations, I went to the factories, and that time I could hardly see any human being even in Korea. It was all either robotics or automated systems that were in place. Obviously in India it is a little bit different. We have in Noida, we started the smart mobile manufacturing in 1996. Obviously, there are a lot of human involvement, but 2018, when we moved, we started changing that landscape also a bit, and it became the largest mobile manufacturing. Now, taking the key points, how the transition is happening, it's from the operator role, human peoples would be a lot of orchestrator. So that's one definitive transformation. If you look into Charlie Chaplin movies and things like that, all human tasks in manufacturing can be identified, and gradually, one day or the other, they will be automated. Some will be happening quicker than the others. So there is a list of actions that are there, and we should see where machines will be taking over quickly, where it will take 2-3 years, 5 years, 10 years. Depending on the problem statement, I think we know the map that is coming. Last point, as it happens, you will also see new roles coming up. Like for example, Siemens has a great digital twin. So simulations of manufacturing, micro-manufacturing, hyper-connected systems, that's a new role. Data operators, those who are just operators, they will also learn a lot of analytics. So new roles will be coming, AI ethics part of it, right? The security, cybersecurity attacks, the threats would be growing, so those would be new roles. Those would be kind of new roles that would emerge, and even the machines, I think humans will certify them. Are they doing the jobs that they are supposed to be doing? So these are new roles that will unfold, I think.
Thank you. Gokul, you're also working on something called visual object intelligence. So can you explain a little bit about it and also its industry application?
So what we build is to address the missing gaps that we have in AI today. So it's an alternate AI stack per se. Robots are not blessed intuitively to handle objects that they have not been trained upon. And like for example, the water bottle that you have today, that's a puzzling thing for a robot to kind of understand because it's transparent. It just assumes what happens in the environment as it is. So these are what we call as litmus paper test for AI per se. So that if a robot is interfaced with in a manufacturing scenario or any situation, real world situation, the same object looks slightly different because of the environmental changes, and so the robot stalls. The ability, but a baby may not even know what this is, but he'll go and pick it and then handle it, right? That inherent ability that robot must also be blessed with so that they become more trainable and what we call as on-the-fly learning or adaptive learning. And the whole set of sensing all the way till intelligence that is absent is what we call as visual intelligence, and that's what we build for robot stack per se. So,
okay, and how come the industry benefit from it?
Yeah, so today the biggest gap in adopting AI-based robot systems or robots for automation per se, right? Contrary to the popular perception, it's only a $16 billion market globally. Just if you think about Ford, their annual wages for blue collar is up and above $22 billion, right? So that's where we are. And that limited a market is because robots have to handle a lot of variations in the environment. Contrary to the popular perception, again, factory is not a standardized set of applications. Object, when its orientation changes in itself, robot cannot recognize them. Most parts come with a wrapper on top of them. Metallic parts just shine. So these are places where the automation is extremely hard. And that seems to be the majority of the case. Picking one bolt, putting into a screw hole such that it doesn't slip is an unsolved problem. Hand start, what we call as hand starting. Nut runners and all those are like automated long ago. But just placement of the bolt, you have a lot of people just doing that. So those kind of activities are the hard to solve problems, scaling all the way from whatever you see as cloth folding videos and things. There are a lot of inherent problems that they have. For industry to adopt general purpose robots in a scalable fashion and be able to defensibly repurpose that robot if the tasks change, your product design changes and so on and so forth, and or if the environment is not controllable largely for you, then you need an ability for the robot to figure itself out in that situation. So that's the biggest barrier for adopting robots also for industry, and that's what we solve.
Thank you. So, you come from a corporate history, working with Samsung Electronics. Then you're also startup founder. And so how, with your experience in a legacy brand like Samsung, how have your experience, the learnings that you have had, you have married that being a startup founder and to what you have created?
So, obviously, we talked about robotics part of the manufacturing, but we have also built AI and IoT. And even in Bangalore, we had built a team of 1,500 people, and I was responsible for global IoT data platform for smart things. But this is for smart home. Samsung is all about digital appliances, home appliances, connecting them, looking at that data. Obviously, I'm not working in that. But what we realized is there are two parts, the IoT part and the AI. When you go into consulting, even for manufacturing, what is the challenge of people adopting AI or IoT? First of all, we tell that do not think about replacing any equipment because people have invested in them. They are working fine, may not be having all the intelligence. So how do you wrap around it? How do you abstract? Do not eliminate, but SCADA and PLC, those kinds of things. Add more sensors, write software, make them more modern. So retrofitting is an important part, number one. Number two, when we launched 5G in 2019, I remember the first application was B2B, going into factories and seeing defect remotely. But there is a lot of latency. So currently, we have improved upon edge AI. So instead of going into cloud, maintaining privacy, reducing latency, how do you bring this layer of edge AI, which are solutions coming, take that and adopt? And third thing we are saying is that manufacturing places, how do you make it more reconfigurable, future-proof? Because you will have a roadmap of 10 years. In manufacturing, there is less standards that are available, interoperability issues. So when you take consulting or take solutions, please keep in mind how these pieces will fit. You will have multiple SKUs that you have to produce in the same factory. How do you reorganize and reconfigure? So that's a kind of learning and that we provide. Now, just the last part of adopting that, what we are building now in the startup is AI for manufacturing. There are a lot of companies who are already plugged into the manufacturing systems. I'm working with them to collect the data. We have an AI app store connecting to the manufacturing. And AI, when you look into it, 3 dimensions, I will say. The first is AI is of 4 types you can solve problem. One is a descriptive, what's happening. Then called diagnostic, why is it happening? Then we say kind of predictive, what will happen? And prescriptive, how will you mitigate if there is a problem? So this is one dimension of problems. So our solutions are kind of addressing different aspects. Second dimension is what are the types of problem? There is supply chain problem that you can solve through AI operations research. You have production planning, scheduling. You also have future issues like sustainability, worker safety, plant safety. So that's the second dimension. And third dimension is about different verticals. Am I solving a problem of electronics manufacturing? Or are we going into steel and metals and materials, waste management? They have a different problem. So I think these 3 verticals we are looking and creating a lot of AI solutions, leveraging, partnering with somebody to get the data who are plugged into the systems and those experiences that I've already highlighted.
Thank you. Moving to you, Gokul, you make solutions for companies such as Jaguar Land Rover. So what's the gap or the challenge between creation of the solution in terms of industrial automation and the zero downtime of smart factories?
Yeah. The perspective, especially on terms of smart factory, right? It's still an evolving concept, right? So it's not like entirely smart per se. And adoption of automation into a line like that of a Jaguar and Land Rovers or any car manufacturing or a sedan manufacturing per se is very minimal. There are like 22,000 parts that go into your car. If you just think about all subparts included, but like 7,000 parts that will go and 10,000 jobs to be done. They are completely manual and across different. It's true for any, including Tesla all the way here to Maruti and Tata or Mahindra too. So many of these tasks are very dynamic in nature and that are like very hard to automate. If at all they want, it's not that we lack technology and means to do it, but if you go about doing it, it's commercially unviable. You need to arrest the variation in the environment to 0.2 mm, and that is for a changing, moving car chassis, it's like kind of very difficult. This also limits the customer from being able to franchisee their manufacturing and defensibility for changing consumer taste. That if I want to change my product design, the nimbleness for you to kind of reflect that in your manufacturing is very difficult because you made a machine that is purpose built for a few shapes and few designs of your product. Now suddenly if you want to go about changing it, you are spending another 36 months, just 15 to 36 months just getting it correct, your process right and so on. So and you become obsolete by the time. The interest becomes obsolete by the time. So it always, you are in an eternal sales and marketing problem to sustain customer interest. So these are big gaps in adopting rigid automation into the factory line. They need a extremely flexible, kind of a modular, what we call as universal factories internally, right? One machine that can scale to all these variations, and a software away from one product line to another product line. So that's a vision towards which all of these new age AI driven automation adoption is happening across industry per se. So yeah.
Thank you. So you have worked across industries such as mobility, telecom, right? So what are the cross-industry lessons that companies can learn which can actually help accelerate Industry 4.0?
That's an interesting question. When you look into, for example, telecom, there is a lot of standardizations. We have 3GPP standards and now going to 4G, 5G. We are working on 6G. So there is this standardization. Even in IoT, there are more standards, but there is standard bodies, so that interoperability is easier. The manufacturing is one piece that doesn't have fully so much of standardization. There is industrial IoT is evolving, but there are other aspects of it still, it needs attention. So I think if you want to take one lesson, I would say from telecom, it will be interoperability, standardization. If you look into mobility that we have been working, mobility is like a cyber physical system on wheels, right? It's a systems. So we can learn for systems engineering. How can you simulate? How can you create digital twins? Physics-based simulations could also help. So I think in the industry 4.0, a lot of simulations and model building could be useful. Manufacturing, if you look into it, the reliability is the key factor, right? Accuracies, reliability, predictability is very, very important in manufacturing. So I think industry 4.0, if I just combine these three, interoperable systems that works, and simulations and twins, and also reliable and accurate, that would be quite interesting. Now, when you look into India, I think a little bit, also challenging and different than the West, because there you can have a lot of automations, but we have tons of people. So we can't just overboard and do automations. So how to leverage people should be an objective when we deploy here. Here, if you look into digital preparedness, to get into an industry 4.0, particularly for MSME, is missing. So we have to do a pre-work, prepare them to get to industry 4.0. So that prerequisite is important. Also, I think we can't use huge capex. Outside, many countries can build machines, replace. Here, I think kind of jugaad solutions. Can you wrap around? Can you bring sensors? Low cost, cost-effective solutions with the same intent in mind. I believe these, if we combine, that could be great.
You want to add to that capex part?
Yeah. So I think there has to be a distinction between infrastructure investment versus output improvement per se, right? So there's a drastic variation between those. So there are businesses that become foundation for, like manufacturing becomes foundation for alternate businesses and things. And there are places where you're competing with in terms of efficiency and so those distinctions will have to happen from that front. And if India intends to compete with the global markets per se, not borrow the labor effort anymore, and that's a space you will increasingly see getting squeezed, and manufacturing going back to the nations of design origin, essentially, because they want to keep it, they are seeing that as a national security issue anymore, or supply chain security issue anymore. The value addition would come more in terms of added value and nimbleness for us to kind of adopt. So some portion of capex investment, I think, has to be thought through. When we react, yes, India is a market that is very, very capex averse from that point of view, right? But if you have to think forward-looking, like semiconductor, if you're investing the way we are investing, often people confuse electronics. It's a broad spectrum. Semiconductor is a very different, very different business compared to a mobile phone assembly per se. It's a different ball game altogether, right? So those will have a differentiation from that front. So.
Yeah, just a very quick point. I think Gokul pointed it right. Semicon, we are just starting fresh. So probably if you are doing, you should be future forward thinking and investing into that. Some that are there and obviously constrained would be a little different way how you can deal with the MSMEs to survive.
Thank you. Both of you have touched upon the challenge part of this. So my last question, the closing question to both of you is, if in 2 lines, you have to summarize the biggest challenge that you are facing, maybe from a company perspective or from an industry perspective, which is the biggest hurdle in the adoption of Industry 4.0?
Yeah, okay. Yeah. No, I think I already mentioned few points that, the preparedness, and particularly we have a huge amount of MSMEs, and I've seen that Belagavi and a couple of other places, we have gone into it. Big companies can operate differently, they have a global footprint, but if we have to move these people up, one important thing is they have invested in it, they have less knowledge, world is moving very fast, we are not clear which data is useful, what AI model do I adopt. So we need a lot of awareness sessions, and some consultant have to closely work with them, understand their pain points and these to lift them up. Otherwise, I have seen from my experience in limited 1.5 year of this startup journey, that it is very hard to move them up. They will do tweaking and trying to get there. So if we give them a roadmap, keeping a broader objective in mind, 5 years, 10 years, but if we give steps, and every step if we tell them, by doing it, you save this, you gain this. You move here, you save this, you gain this. Saving in not just cost, but in terms of anything. Quality, getting market shares, newer businesses, anything of that nature. And a niche product, if they are doing 10 different things, maybe cartel 3, specialize into 2, this kind of guidance, and modernize the factory in whatever is required to do these 3 well, so that you can get an UAE market or other markets. That will be great.
Out of 10, you would have to rank this journey, like 4.0 adoption in India. How would you mark this now?
3.5.
Long way to go.
Yep.
I'm pretty much on the same page. 3.5, I'm 100% in the flow. So,
not even pass.
So, I think I'm going to split into multiple stakeholdership point of view to see the one big challenge is India is a follower mindset in investing into infrastructure upgrade, especially because we are looking at India as the market, not the globe as the market. If that mindset shifts, the way we are thinking around semiconductor and so on and so forth, so if all the family houses also start thinking, and it's very family house centric in the top layer where the manufacturing actually happens, if that change and perspective happens, adoption and value for Industry 4.0, where it makes commercial sense, could be made more evident. Right now, you're thinking through labor, right? Businesses are not thinking through machinery and automation and adoption, and what kind of velocity it can actually kick more for you to capture outside markets and other manufacturing peers across the globe, right? So that thought process has to change. Second, absent talent. India is, it's even to structure this for the country in the way we operate. We have an infrastructure ecosystem support that is absent for Industry 4.0 also, because everything is imported per se for us to realize this in the first place. Second, you also have lack of talent to set the framework for this, right? And then goes all the way till implementation. That's another gap per se in a big manner. And if we have to do that, we need to be opening up a little bit more like the way Japan opened up to the US in its early 60s and 50s. That would be necessary for even the industries to see success, initial success, because that becomes a catalyst for this ball to start rolling. Otherwise, it's a jugaad attempt in many cases, and half-hearted investment, and it doesn't pay out in a good way, and then again it just becomes a self-fulfilling prophecy in many cases. So if this cycle has to break, you need to bring in the experts to think through this, and you also have to have the willingness to bear the cost and then move that, expand the business in a different way. So both sides.
Many thanks to both of you. Thank you so much.
Thank
Is there anything else that you would like to add?
Now, I was just about to say that even though it's 3.5, but if we can take them to 5, I think it will self-accelerate thereafter. Because once people get a grip on how to use AI data in baseline, and they are seeing benefit and ROI, then they will spin, and they have got one market, then why not second market? So even though it looks a long journey, but we have to take them to 5. Then after that, there would be...
Will you change your marking?
When that happens, I can't predict. It can even hit 10. I mean, if you get your cycle moving. So that's what he's saying, that moving from 3.5 to 5.
After that, it could move quite faster.
So figure that piece out, then you will become self-sustaining, and it will move.
Thank you.